Hello all. Now we'll learn about bacterial growth curve. When bacteria are inoculated into a fresh medium, they undergoes growth and division. Number of these bacterial cells which are formed in a medium can be counted and it can be plotted against time. And a graphical representation which is obtained by taking the number of dividing cells of bacteria and the number or the time interval between each of this division, you will get a plot which is called as a bacterial growth curve. And this bacterial growth curve is having four phases: lag phase, log phase, stationary phase, and senescence or death phase. First, we'll discuss about the lag phase. Lag phase is the first phase in bacterial growth curve, and as the name implies, it is having a lag for all the activities of the bacteria. And during this lag phase, the bacteria is not dividing, it is not increasing in cell size, and it is not increasing in cell number. But still, there are certain metabolic activities and preparations are happening during this lag phase. And there are several reasons why this bacteria is undergoing through a lag phase for the first during the first phase of this bacterial growth curve, and we'll analyze which are the reasons. First one is that the lag phase can be due to the depletion of ATP, and the microorganisms may be too old. The bacteria that you are using for the inoculating into a medium, it may be too old and it may be depleted of ATP. So it requires new energy molecules and they need to be completely active to use up the nutrients in a new environment. That may be the first reason a lag phase can happen. The second reason is that they requires ribosomes and essential cofactors. And the medium that they are now, it will be different from that of the previous media. And the nutrients composition of the media is also different. And during this time, the bacteria cannot use the same machineries which they used previously for utilizing the nutrients in the new media. And for that purpose, they need to synthesize new ribosomes and new proteins, enzymes, cofactors, etc., for utilizing the nutrients in the new medium. So that's another reason why there is a lag phase. Another thing is that the medium can be totally different. That means the total environment of the medium can be different from that of the previous one. So the bacteria gets some time, or it needs some time to get adjusted into a new condition or new environment. Another thing is that the bacterial cells, almost of them can undergo some injuries when they are undergoing growth if they are coming from a densely populated culture system. And these injured cells, even if you introduce in a fresh medium, they won't suddenly undergo the division process, but they take some time to recover all those injuries. But after all these activities, or after all these recovery processes, they undergo retooling, replication, they increase in cell size, and finally they divide. So these are the characteristic features of lag phase. Now we'll move on to the second phase, which is called as exponential phase or log phase. Exponential phase is so called because you can see a marked increase in the number of bacterial cells. Because all the preparations have been completed during the lag phase, now the cell have increased its size and it is capable of undergoing the division process. And here the cell starts to divide, but in a regular interval of time or at a constant rate. That means if a cell is dividing once in 2 minutes, when it gets into a 4 minute, you can count four number of bacterial cells. Like that, it is dividing in a constant rate. And due to this reason, you can find out what will be the number of bacterial cells at a particular time by this formulae. For example, 2 raised to n is considered to be the number of bacterial cells which are found at particular time. That means the bacteria is dividing in the multiples of 2 and it can be counted at regular intervals of time. So you'll get a perfect calculation about the number of bacterial cells currently present at that particular medium by calculating the time also. So here it is said that the bacteria that are there in the exponential phase, they will be having uniform rate for all their activities. For example, the metabolic process they are undergoing, the synthesis process or the behavior of the cells, the division rate, everything is constant in the exponential phase. And due to this reason, if you are taking a bacterial cell, then that will be the representative of all the activities of other bacterial cells, since they are having a uniformity in all their activities. Hence, the industrial purposes and commercial purposes, this bacterial cells at the exponential states have been used for maximum production, and that's the peculiarity of the exponential phase. And this exponential phase two types of growth can happen. One is balanced growth, second one is unbalanced growth. Balanced growth is something in which all the bacterial cells are behaving in a uniform pattern, or synthesis is happening at a constant rate. We call them the balanced growth is happening. But unbalanced growth, there is another phase. Here it is unbalanced, it is happening is due to the accumulation of waste, or sometimes the overpopulation of the bacteria, then lack of oxygen, and other reasons like nutrient depletion, etc., can be the reasons for this unbalanced growth. And here, if you look at a bacteria, not every bacteria will be at the same phase of their growth, or not every bacteria will be synthesizing, or they won't be dividing at a constant rate. So that is called as unbalanced growth. So in stationary phase, balanced growth usually happens. That's why we say that all the bacteria in the exponential phase is having a regular pattern of activities and regular behavior of division and synthesis. The exponential phase or log phase is followed by the stationary phase. Stationary phase is something, from the name itself we can say that there is no increase in a net increase in the number of bacterial cells. What is happening in the stationary phase is that after some rounds of division, the bacterial cells will increase in that particular medium and uses up all the nutrients, and as a result of the metabolic activities, toxic waste used to get accumulated, and some of the cells, due to our population, they goes beneath the surface, and the aeration will be obtained, or the oxygen will be received only by the cells which are at the surface. So there are several reasons for this. So during this time, the bacteria may not be able to divide in that pace like that of the exponential phase. Here their division, it slows down, but some of the bacterial cells are still undergoing division. And during this phase, some of the cells, along with division, some others are undergoing death also. So here stationary phase is obtained because the number of cells newly formed by division process, it equalizes the number of cells which are undergoing death. So there is no net increase or decrease in the number of bacterial cells. And when you observe the plot, you can see that there is a stationary condition, or a plateau which is formed. There is with no elevation or depression in the plot. That's the stationary phase, and these are the various reasons why there is a stationary phase is happening. Now, just we'll go through the reasons why there is a stationary phase. One is that the oxygen availability. For aerobic organism, it is very important. They need to have continuous supply of oxygen. And as we said earlier, when the cells get overpopulated, some of them goes beneath the surface, and those cells will not receive oxygen, and they will be undergoing death gradually. And another reason is that even if they are receiving oxygen, due to their overpopulation, they won't be having much space to grow. And due to this reason also, the number of cells cannot be increased by the division process. Another thing is that the nutrient supplies. Since it's a closed system means something in which we are not renewing the nutrients, we are not replacing the components, and we are not removing the toxic waste. Whatever we are providing at the beginning, till the completion of this culture, you are having the same components. We are not making any changes in this medium. That kind of systems are called as closed system. And here we are performing these bacterial growth curve experiments in a closed system. That means there is no removal of waste and renewal of nutrients happening. So here, due to the accumulation of toxic waste, and this toxic waste are actually formed by the metabolic activities of bacteria itself, and this act as a hindrance for the growth and division of the nearby bacterial cells. That is another reason why there is no division happening. Next is that the nutrient limitation. The nutrients that are already provided in a closed system, it gets depleted gradually by the activity and feeding of this bacteria, and there is no more nutrients are available. During this time, the bacteria, they slows down their division and think more of their survival than dividing. So these are the various reasons why there is a stationary phase. And stationary phase is followed by senescence phase or death phase. And senescence phase or death phase, it is characterized by a decline in the number of dividing cells. Here there is no dividing cells are there, or no new cells are formed by division, but they are undergoing a condition in which they are metabolically active, but they are not dividing. So it can be divided into senescence and death. Both are different terms. This senescence means the bacteria are remaining in a dormant condition or a quiescent stage. Here the cells are metabolically active, but they are not dividing. The cells which are undergoing senescence, they can be of two types. One is viable cells and non-viable cells. Viable cells are those cells which are not dividing now, or they are metabolically not completely active, but they are remaining in a dormant state, but they haven't lost their potential for dividing. That means if you are taking these viable cells in the senescent stage and if you are putting it in a fresh medium, and after some time they start to use up the nutrients in the new medium and they will start to grow up and divide in new medium. That kind of cells are called as viable cells. But there are another group which is called as non-viable cells. Non-viable cells are those cells, even if you are transferring it into a new medium or fresh medium, they have lost all their viability or their potential, and due to this reason they cannot use up the nutrients and they cannot grow in a new medium. That kind of cells are called as non-viable cells. So in senescence there are viable cells and non-viable cells, and these non-viable cells, they gradually undergoes the process of death. Cell death means it is a complete destruction process of the cell. That means the cell is not in a dormant condition, but they already receive the signals for death. That means they know that they are going to be dead or they are destined for death, and during this time the cells lyses. The cell lyses and releases all its content to the environment, and totally they will be destroyed. So that is the difference between senescence and death. And that death process is not actually a totally, you cannot say that it's a complete stop process, but instead these particles or the lysis products that are released into the environment, it can be used by the bacteria, the nearby bacteria which are healthy, or the bacteria which are not lost their potential, and they can use it for their growth also. So these are the different phases in the bacterial growth curve, and I will look at the graphical representation. You can see in the x-axis the time is given, and in y-axis a log number of bacterial cells which are forming and dividing. Four phases are shown. First was the lag phase. In lag phase there is no increase in the number of bacterial cells. Number of cells that you're adding at the beginning is the number shown here, and there is no net increase or decrease. This is the time taken for the bacteria for some preparations and to get adjusted to the medium. Now it is followed by the exponential phase or lag phase, and it is called as exponential because there is a steep increase in the number of bacterial cells happening at a constant rate at a constant time, and which is followed by stationary phase. Here there is no net increase or decrease in the number of bacterial cells, but there is no decline. That's the difference. There is no decline. The number of cells formed newly here is equal to the number of cells which are undergoing death. So there is no net increase or decrease, which is followed by the death phase. Here you can see that there is a steep decline in the number of dividing cells formed, and finally it reaches zero when all the bacterial cells are dead. So as a summary, if you look at the bacterial growth curve, we already said that it is a graphical representation of number of bacterial cells formed at constant rate of time. It is having four different phases: lag, log, stationary, and death phase. And studying all these phases, we can find out what are the activities happening during the life cycle of a bacteria, and what are the preparations or the division process, and also how they are dividing and how they are behaving at different phases. So that's all about the bacterial growth curve. Thank you.